Hi my friends. The other day I found this object on the net. All of us know what is this, but the interesting thing is that the coil is on the left. When you rotate here, the coil works in this way. And I thought, why not to model this part? And I created this object. You see, it is very real and very nice. Let's model this. You understand that starting from here, I had to create the drawing, the technical drawing. This is the technical drawing for this part, and you can see I placed a lot of dimensions here. The section of the worm is dimensioned here, and you understand that this is in a plane which is contains the axis of the part. It is not a sloped plane, it is a front plane. Good. Knowing this, we try to create the object. New IPT standard millimeters. This plane, and now we draw the section. What section? This one. Half of 14, the base, and this contour with radius 1 at the top and diameter of 44.9, and this is 45. Line, somewhere here, back, and down, equal to these two sides. Tangent, we have to be sure of tangencies. Okay. Project the axis Z. Make it center line. Diameter of 14. The same vertical, this is vertical, yes, for this point and the center point. Radius 1, and the diameter of from here to top, not 41, but 45 minus 0.1. You will see why I place here 44.9 instead of 45, as you expected. One dimensions needed. This is the base, which is 8 millimeters, as in the drawing. Once again, we see here 8 millimeters, radius 1, 45 4.9, which is 45 minus 0.1. Good. Remember the coil height, 81.5, and the pitch. We'll select for the coil pitch and height as a reference. Let's do this. Finish sketch, coil, pitch and height, not pitch and revolution, not revolution and height, not spiral, but pitch and height. The pitch is 24, the height is 81.5, and the direction is left hand, not right hand. So I select this icon. There is a profile, there is an axis, then we can apply. Okay. Next we have to split the ends of this coil, because you see here this is a cut. Yes, a cut made at the plane XY, and the other end is somewhere inside the small cylinder, this cylinder. So I activate the plane XY, I make visibility, and I apply split. What is the tool for split? This plane. And then I select the solution. Keep side, this is to be kept. Yes? Okay. Now I have this cut. Then I create a new plane based on this one, and through this vertex, the center of the arc. Another split, this is the tool, and we must keep this, and this is to be cut. Okay, good. This is not necessary, this is not necessary to be present, and we go to the core. The core is a revolution volume. As you can see, is this with this contour, and dimensions are all here. Let's draw this contour to start the sketch. The plane is this one, and we draw the contour. Up, right, up, right, up. Now we go somewhere here, again up. I don't make this next line collinear, and I'll show you why. I close this with a center line, close. I disable center line. I place the center line on the center point, and then dimensions. Eight diameters first, 11, 14, 14, you see there are two dimensions here, 14 and 14. The designer decided to place two dimensions, so we have to respect this option. 45. On the other direction we have 10. This is 6. Here is 6. Then 84 is this line. From the end to the center point, or this face, is 0.5 millimeters lower, 83.5. Okay, and the general dimension of 150. 150. Good. I arrange them a little to be more compact here, and we have two dimensions of 14, as I said. This is the sketch. Revolve. Okay. Then we have to apply some cuts. You see there is an end with a square feature and another end with another square feature. 8.5 is the dimension of one, and 11 is the other. So let's create these two cuts. 8.5 is this one. We create a sketch here with a polygon, 4 sides polygon. We start from the center and we place it here. F7 to see the center point. This is on the same horizontal with the center point, and the dimension is 8.5. finish sketch. I want to look from this direction to be sure that I select only this kind of segments to be cutted. The other direction, this means cut to this face. Yes? Okay. The other end with another sketch of a square with the center here, the same horizontal but now you see Y is to the right, so I have to select the other constraint to place this, as you can see, and then a dimension of 11. Finish sketch, F5, extrude segments, 1, 2, 3, 4. The length of this is 12, so I go to the inside and I write here 12. You see this dimension of 12. Good. Next, I apply fillets. This is radius 1, radius 1. Radius 0.5, radius 0.2, but an important one is this one on the sides of the coil, 4 millimeters. We start with this. This is the first. So we go here inside to see the line, which is this, radius 1. Yes, and radius 1 is also this one, plus this, which is 0.5, and the other one, which is 0.2, plus this one, which is because of the first fillet is connected on the both faces. Okay, F6. Now we add some minor fillets of 0.2 to have no sharp edges at any side of the part. Okay, there is a specification here. Undimensioned chamfers are 0.5 at 45, so let's apply them. This is one of them, chamfer 0.5, and here 0.5, apply. We try to place here 0.5, but it seems to be not natural, not possible. So I change this, overriding the specification with these values. Okay. F6. The material is steel, stainless steel, and the part is really finished, my friends. Let's see what about the volume. I properties, physical, update. This must be considered the value instead of this value, because we made together. There is not a big difference, I suppose. So we place here this value which was created during our modeling. That's all for today. Thanks for watching. Bye bye, my friends.